Hello, see this problem here. This is the wedge of mass capital M and 60 degree each of these angles, and there are two blocks M1 and M2, and these two blocks are free to slide down this wedge because there is no friction between the wedge and the block, while there is friction coefficient mu between this wedge and this ground. In the figure, find minimum value of mu for which the mass M, that means the wedge of mass capital M, doesn't move, and the masses are given. So let's draw the diagram. Now let's see the diagram, free body diagram of this block. See, obviously the normal reaction on this block is m1g cos 60. On the other block it is m2g cos 60, and same by Newton's third law, same normal reaction will act on the wedges, and that too this will have horizontal component and vertical component. This also has horizontal component and vertical component, and for the wedge mg, and normal reaction is n. Which one is greater? So m2. So on the wedge, the net force on the wedge, let's calculate the net force on the wedge in this way. It is m2 minus m1 g cos 60 into cos 30. So cos 60 into cos 30 means half into root 3 by 2, so root 3 by 4, and this force is m1 plus m1 plus m2 g cos 60 into sin 30, so is 1/4, so by 4. Apart from this you have capital Mg, so this is normal reaction n, and this is friction coefficient mu n. So therefore you know n, so n normal reaction is equal to m1 plus m2 g by 4 plus capital Mg. 1 plus m means plus 2 3g by 4 plus capital Mg means 3g by 2, that is it comes out to be 4, you have 9. So it is 9g by 4. Normal reaction is 9g by 4, and the applied force, say, this is called F. Now this mu n is also equal to this F. So this F or mu n, F or mu n is equal to m2 minus m1, that is 1g root 3. So root 3 g by 4 mu n. So mu times n. So therefore mu times 9g by 4 is equal to root 3 g by 4. So 4 will cancel out, g will cancel out, therefore root 3 by 9, root 3 by 9. So it is 3 to the power half by 3 to the power 2, that is implies 1 by mu is 3 to the power 2 minus half, that is 3 by 2, 3 to the power 3 by 2. Okay, so that means alpha is equal to 3, because it is given in the problem. You can express alpha, 1 by mu is alpha to the power 3 by 2. So see, alpha is equal to 3.